so that's ionization energy. Our next trend is another one that we also looked at. And it is atomic radius. All right, atomic radius is the measure of the size of an atom, or we can say that it's the distance from the nucleus to the surrounding clouds. So when we're talking about atomic radius, we're dealing with the size of an atom, how large the actual atom is. So for this one, the trend is the closer you get to francium, the larger the atomic radius. So that means that our trend is going this direction. So francium is our largest. And as we go down the periodic table, we increase. And as we go from right to left, we would also increase. So obviously the opposite of that would also be true. As we go from the bottom to the top, we would be decreasing in size, or if we went from left to right, we would decrease. So they're getting smaller that direction, since francium is our largest. Why? Well, this one we have two different factors to take into place. All right? Let's talk about down a family first, because down a family first makes the most sense. So heading down, it would make sense that elements get larger as we move down a periodic table, because every row that we move down, we add on what? What do the rows tell us? The rows or the periods on the periodic tell us how many what an atom has. Okay, it tells us that, but more specifically, what are those things called around? The energy levels, okay? So the first row, it only has one energy level. The second one has two. The third one has three. So row 7 has 7 energy levels. Well, would it make sense then if as we move down a periodic table, an atom gets bigger? Yeah, because as we add more energy levels to it, it's going to expand out. So it makes sense as to why heading down the table, an atom would get larger. Yes. Yes. All right, because we're adding more energy levels. the left to right is the one that you kind of have to really understand how an atom is formed in order to understand why, if we're moving left to right, we have more particles. That means that we get smaller. Because most of the time we would think if you're adding more of something, then it should be larger. But it actually works the opposite. So as we're moving from left to right on the periodic table, here's what happens. The more valence electrons you have, the closer they pull their energy level toward the nucleus. All right, coming up through science, you probably all heard of the expression opposites attract. Positives attract negatives, negatives attract positives, right? Electrons are negative, protons are positive, they're located inside of the nucleus, okay? So here's what's going on as we move from left to right. The first family only has one valence electron. So one valence electron is spinning around that outer energy level. It's not going to be able to pull that energy level in very much because it's only one electron. Move all the way to the other side, to the noble gases, who has 8 valence electrons. So now they have 8 electrons that have each their own strength to be able to pull that outer energy level more towards the center positive nucleus. So this is why as we move from left to right, it's getting smaller as we go, because the more electrons you have on the outside, the greater the force can be pushed inward towards that nucleus. All right, so what does this look like if we're doing examples of them? So let's put these in arrangement from smallest to largest. And let's say we have phosphorus, magnesium, chlorine, aluminum, and sodium. So we're still dealing with the same elements, only now we're going to arrange them according to size. So who would be the smallest? Cl. All right, who would be next? P. All right, then would come aluminum. Next would be Mg. And finally would be Na. All right, let's do another one. Let's say we went up and down a family. So let's say we have barium, magnesium, calcium, and strontium. So these are all part of the alkaline earth family. So who would be the smallest in the family? Mg, because it's at the very top of the ones we have anyway. All right, who would be next? Ca. Next would be Sr, and our largest one would be Ba. All right, questions on how we use atomic radius?